Okay, we have here today another integral on the board. This one's from the Columbia Integration Bee 2022, problem number 3. We have the integral of natural log x squared plus 8x plus 17 dx. Okay, now the interesting thing with this problem is we've got a lot going on inside the natural log. You don't usually see like a quadratic, like that inside the natural log. Now, typically when I have natural log, I'm thinking integration by parts. But because it's a little more complicated than just natural log x or natural log x plus 1, I think I might want to do something with this and try to handle this thing first. So what I think I'm going to do is complete the square on this. So taking 1/2 of 8, I can write x plus 4 and square it. And then just notice if I square this out, I'm going to get x squared plus 8x plus 16. In order to get my 17, I just need to add 1. So now let's just rewrite this thing in this form here. So I'm gonna have my natural log x plus 4 squared plus 1. And then from here, I think I'm gonna do a u substitution just to clean this up a little bit and simplify it. I don't know that we need to, but I just kinda like to do it this way. So I'm gonna say I'm gonna call my u equal to x plus 4. And that's nice because then our du is gonna be just dx. So then we're gonna have natural log of u squared plus 1 du. And now at this point, I think I'm ready to do integration by parts on this. I'm going to use the DI method or tabular integration. And so this is a lot like the natural log of x case, but we're going to want to differentiate natural log because we don't really have a good way to integrate it. So we're just going to differentiate the whole thing. And what am I going to integrate? Well, I'll just kind of create a 1 here so I can integrate this 1. Then we'll go ahead and get our derivative here. So this is going to give me 1 over u squared plus 1. And then we need the chain rule. The derivative of this part is going to give me just a 2u here. And then integrating 1, that's just going to give me u. So then we're going to have part of our solution right here on the diagonal. So let's write that in. So we're going to have u natural log u squared plus 1. And then here, this row is going to be an integral right here. So what I'm going to do is I'm going to take a minus sign out front, and I'm also going to take my 2 out front. And then we're just going to have u squared over u squared plus 1. But now the way I can make this really easy is if I just add a plus 1 here. Now this integral is 1. I don't want to change it, so I'm going to subtract off 1. And so we'll take this minus 1 and create a separate integral. So let's see what we have. So again, what I did here is this actually became a 1. So that's how I'm integrating 1 here. And then I distribute minus 2 to minus 1, and we get this plus 2 out front. And then the denominator, we're just going to have u squared plus 1. But let me just clean up the board so I can get some more space. Okay, now at this point we're almost done, but we just have a couple easy integrals to do. So let's see, I'm just going to copy this piece down again. And then integrating 1 here is just going to give me a u. And then here, the integral of du over u squared plus 1, this is going to just give me arctan of u. So now I just need to back substitute to all these u's. And so what we're going to have here in front, we're going to have this is going to become an x plus 4. Now here, when we do u squared plus 1, this is actually going to just get me back to this original x squared plus 8x plus 17. So I'm just going to write it in that form. I'm going to expand it out. Then here we're going to have minus 2 times x plus 4. This is going to give me a minus 2x. Minus 2 times 4 is going to give me a minus 8. But I'm going to skip that because we're going to have a constant on the end. And that's going to absorb the minus 8. So I'm just going to leave that off. And so for the last piece, we're going to have just 2 arctan of x plus 4 plus c. And that's it. Okay, good problem. I'll do some more of these from the Columbia 22 Integration Bee. So I'm stopping it there. Thanks everyone for watching today. Have a great day.